Welcome. I am Professor J. N. Mandal, Department of Civil Engineering, Indian Institute of Technology, Bombay. I will now teach the grain size analysis of soil. This is very important for every structure that one should know what will be the grain size distribution of the soil. So, our main objective how to determine the grain size analysis of the soil. The average representative of the sizes of particles in soil drawn on semi-logarithm plot of diameter size on the logarithm scale and percentage finer on arithmetic scale represented the grain size distribution of the soil. Three general procedures of analysis are adopted to achieve the final gradation curve. First of all, we will talk about the dry sieving. In case of the dry sieving, it is used for clean sand and gravel. The soil is placed on the top of the sieve rack and then sieved it. Then wet sieving. The soil containing silt and clay must first be washed to remove the fine particle which pass through 75 micron sieve. The material retained on 75 micron sieve can then be used for dry sieve. Thirdly, sedimentation analysis. In case of sedimentation analysis, the material passing through 75 micron sieve is collected and used for sedimentation analysis. Now, for these different types of the analysis, we require different apparatus and the accessory. So, for the sieve analysis, we need a set of sieve and which form 35 millimeter to 0.075 millimeter. We require the sieve shaker and the balance of 0.1 gram accuracy, then drying oven to dry the soil and porcelain dishes for drying the sample, and then was bottles. So, here I am showing the different sizes of sieve. This is 19 millimeter, this is the lead on the top, this is 19 millimeter, 16 millimeter, 13.2 millimeter, 10 millimeter, 9.5 millimeter, 6.7 millimeter, 4.75 millimeter, and then at the end pan. And this is the lead about 2.36 millimeter, 1.12 millimeter, 0.6 millimeter, 0.425 millimeter, 0.212 millimeter, 0.125 millimeter, and 0.075 millimeter, and then pan. This is the sieve shaker in which you can put the sieve here and you shake it for a particular time. And this is the wash bottle, this is the weighting balance, this is the sieve, one portion of the sieve is shown here, the soil is on the top and this is the portional dish which we determine the moisture content of the soil. So, these are the accessory are required to perform the test of sieve analysis of the soil. Now, next I will talk about the procedure for the sieve analysis. The first stage is mean for coarse grain soil. So, we will talk about the coarse grain soil. Soak about 500 grams of air dry soil in the tray. Now, you have to add a pinch of sodium carbonate to aid the dispersion and mix the mixture thoroughly. So, that is why it is needed to add certain amount of the sodium carbonate on the soil. Keep the mixture for soaking for at least an hour. Wash the mixture of 4.75 millimeter sieve under the current of water and collect the fraction retained on the sieve. Now, transfer the fraction retained on the sieve to proclaim dish and keep it for drying in the oven. So, this is the procedure, and then pass the dried soil through set of sieve from 38 millimeter to 4.75 millimeter as I told you, and record the weight of the soil retained on each sieve in the record sheet. Then next you have to calculate the percentage soil finer than the various sieve sizes. The soil passing through 75 soil passing through 4.75 millimeter sieve is subjected to fine sieve analysis. Take the 100 grams of soil sieve from 4.75 millimeter sieve, then soak the sample for an hour in water. Wash the soaked sample of 75 micron sieve. Keep the soil retained on the 75 micron sieve in oven for 24 hours. Sieve the dry soil through the set of sieve from 2.39 millimeter to 75 micron and record the weight of the soil retained on each sieve in the record sheet and record the weight of the soil retained on each sieve in the record sheet. Now, how to calculate for the sieve analysis? In order to combine result of the gravel with that of the fine sieve analysis, percentage finer N calculated for the sieve analysis is modified. Now, modified that percentage finer N dash is equal to N into N dash G divided by 100. Now, N dash G is the last value of percentage finer in the gravel analysis. You can calculate the coefficient of uniformity that is Cu. Cu is equal to D60 by D10. You can calculate the coefficient of curvature, that is Cc. Cc is equal to D30 square divided by D10 into D60. Here D represents the apparent diameter of soil particle and its subscript denote the percentage smaller than D. For example, D10 is equal to 0.15 millimeter, means 10% of the sample grains are smaller than 0.15 millimeter. Now, how to calculate the specimen calculation for the gravel analysis? So, for the specimen calculation for the gravel analysis, let us say that weight of the air dry soil is taken about 500 gram. Now, hygroscopic moisture content of the soil is 10%. Weight of the oven dry sample will be 4 gram. So, weight for water will be 46 gram. Now, this is the some specimen calculation for the gravel analysis. So, for this specimen calculation for gravel analysis, I am showing here that initially we are taking the weight of the air dry soil. This is a specimen calculation for the gravel analysis. This is the sieve opening size, that is starting from 19, then 16, then 13.2, then 10, 9.5, 6.7 and 4.75. This is weight of the soil retained 131.46, 9.09, 45.96, 30.60, 2.3, 20.1 and 6.98. And this is the percentage retained, this is 28.96, 2.00, 10.12, 6.74, 0.51, 4.43 and 1.54. Then you calculate the cumulative percentage retained. This 28.96, 30.96, 41.08, 47.82, 48.33, 52.76 and 54.30. Then you have to calculate the what will be the percentage final, that is N. N will be 71.04, 69.04, 58.92, 52.92, 51.67, 47.24 and 45.70. I am showing in one serial number that how you are calculating this. So, for example, that what will be the weight of the soil retained is 9.01. Now, how to calculate the percentage retained? So, percentage retained can be calculated by this is 9.09, this divided by, you know that soil retained was 454. So, 9.09 divided by 454 into 100, which will give that 2%. So, percentage retained is about 2% here. Now, you have to calculate the cumulative percentage retained. So, cumulative percentage retained is here 28.96 plus this 2%. So, if you add, then it will give 30.96%. So, this is cumulative percentage retained 30.96%. Then you have to calculate what will be the percentage final N. So, percentage final N will be the 100 minus 30.96, it will give 69.04%. So, this is the percentage final for the calculation for the gravel analysis. So, like that you can calculate for the other sieve opening size, and correspondingly you can also calculate what will be the percentage final. This is one specimen calculation for sand analysis. Let us say that weight of the air dry soil is 100 gram. Weight of the air dry soil is 100 gram. And the hygroscopic moisture content is 10.10%. So, weight of the oven dry soil is 90.83. Now, this is the sieve opening in millimeter, 2.36, 1.18, 0.600, 0.425, 0.212, 0.125 and 0.075. Now, weight of the soil retained in grams is 1.656, 6.397, 2.624, 3.693, 5.686, 5.343 and 3.099. Now, what will be the percentage retained in percentage? Just say 1.82, 7.04, 2.89, 4.07, 6.26, 5.88, 3.41. Then cumulative percentage retained 1.82, 8.86, 11.75, 15.82, 22.08, 27.96 and 31.37. So, percentage final in will be equal to 98.18, 91.14, 88.25, 84.18, 77.92, 72.04 and 68.63. Now, we have to determine what will be the corrected percentage final, that is N dash. So, N dash is 44.87, 41.65, 40.33, 38.47, 35.61, 32.92 and 31.36. Now, you know that how to, from the sieve opening size, you know the how to calculate the weight of the soil retained, you know the what will be the percentage retained, you know the what will be the cumulative percentage retained, also you know how to calculate the percentage final. Now, you have to calculate that what will be the corrected, what will be the corrected percentage final, that is N dash. So, corrected percentage final N dash can be calculated, this N into N dash G by 100. So, what N dash G is the last value of the percentage final in the gravel analysis, that is 45.70. So, this is, you can see this is the specimen calculation for the gravel analysis, and this last value percentage final, that is N, is 45.70. So, this is last value you have to take into consideration for the determination of the corrected percentage final. So, corrected percentage final N dash will be equal to N into N dash G, that means this N dash G is 45.70 and N is equal to, this is percentage final, that is 98.18. So, N 98.18 into N dash G from the last value for earlier gravel analysis, that is 45.70, this divided by 100, this will give you 44.87. This here 44.87. This is the corrected percentage finer, that is N dash. So, this is the different type of the soil specimen that after the analysis. So, you can see some soil as the finer, some soil as the coarser, and at the end you are to draw the curve between the grain size and the percentage finer. So, here it is the gradation curve, and this axis is the grain size in millimeter, this is in log scale. Okay. It's starting from 0.001 to 100, and this y axis is the percentage finer. So, this part we have calculated from the gravel analysis, and this part we have calculated from the sand analysis. So, this is the curve for the gravel analysis, and this is the curve for the sand analysis. So, you know the what will be the percentage of the finer, you know the what will be the grain size of the sample. So, you can draw the grain size distribution curve for the gravel analysis and the sand analysis. So, this way we have to draw the gradation curve of the soil sample. So, next we will discuss that hydrometer analysis, and that is required when the material passing from 75 micron is more than 12%. So, it is widely used method of obtaining an estimate of the distribution of the particle size from 0.075 millimeter to around 0.001 millimeter. So, we record for the hydrometer analysis in such case. So, for the hydrometer analysis it requires the certain law, and that we say that this is the Stokes Law. So, you should know that what is the Stokes Law. Okay. So, Stokes Law, this is the terminal velocity is equal to gamma s minus gamma w divided by 18 into viscosity of water at room temperature eta into d square. This also can be written in this form, that is d is equal to 18 into eta divided by gamma s minus gamma w into root of v. What? V is the terminal velocity, and this gamma w is the unit weight of water, that is gram per cc. Gamma s is the unit weight of the solid, that is gram per cc, and this eta is the viscosity of water at room temperature, and this d is the diameter of the grain. So, from this equation you can calculate what will be the diameter of the grain. So, we use the Stokes Law, from which we can determine the diameter of the grain. To obtain the velocity of fall of the particle, hydrometer is generally used. So, So, soil suspension of about 1000 centimeter cube is made by mixing the given quantity of water with the soil and small amount of dispersing agent such as sodium hexametrophosphatic phosphate, that is NaPO3 or 6, to form a dispersing agent is added to neutralize the charges on the smaller particle or grain. The hydrometer display the specific gravity of the soil water dispersion at the center of the bulb. I will show you that what is the center of the bulb. So, this is the your soil hydrometer for hydrometer analysis, and this is the jar in which water and soil are there, and this is the hydrometer, and this is the reading. You have to read this hydrometer here. So, this hydrometer and from here to here about 130 to 150 millimeter, and this about 150 to 170 millimeter approximately, and this is 30 millimeter, this is 60 millimeter, and this is 50 millimeter, and from here to here about 10 to 20 millimeter. So, this is the soil hydrometer for the hydrometer analysis. So, we will use this hydrometer for the determination for the grain size of the soil. So, before that hydrometer analysis, it is required some correction to hydrometer reading. So, first correction is the meniscus correction, that we designated as CM. Since the soil suspension is not transparent enough, the scale has to be read at the upper rim of the meniscus. That means, this upper rims of this meniscus you have to read, and this which we give the value of Cm for the meniscus correction. This is the hydrometer, this is the water, and this is Cm, which you have to measure to read the upper rim of the meniscus. Now, this correction is additive to the actual reading, because density reading on the hydrometer stem increases downward. Now, there is a dispersion correction which is designated at CD, because the addition of the dispersing agent result in the density of liquid in which sedimentation takes place, being greater than that of water. So, this dispersion correction is also needed. So, to obtain the dispersing correction, 100 centimeter cube of dispersing agent solution is taken in a standard measure cylinder, and the volume is made equal to 1000 centimeter cube by adding the distilled water. Now, this is the cylinder, okay, that is about, this is the cylinder, that is about 1000 centimeter cube, and then you have to add the distilled water, then hydrometer, this is the hydrometer, and then hydrometer is inserted and the reading is taken. This reading, hydrometer reading, is inserted in the standard measure jar filled with water and reading is taken. So, difference between the two reading gives the dispersing agent correction. So, one times you have to take with simply distilled water, the other time you have to take with the dispersing agent, and then you take the difference between the reading which will give you the dispersing agent correction. So, it is always subtracted from the hydrometer reading after it is corrected for the meniscus. So, these are the correction are required for this sieve analysis. Apart from that, there is a temperature correction that is denoted as CT. The hydrometer reading is calibrated generally at a temperature of 27 degrees centigrade. To apply the temperature correction, take cool water and note the hydrometer reading corresponding to the temperature at an interval of 2 degree to up to 33 degree centigrade. If the temperature is more than 27 degree centigrade, then suspension is lighter and the correction is positive. If the temperature is less than 27 degree centigrade, the suspension is denser and the correction is negative. So, ultimately you are to take all the composite correction, that is very important. You have to take the meniscus correction, dispersion correction and the temperature correction. So, total composite correction C will be equal to the Cm minus Cd plus Ct. Thank you.